Hey guys, Mr. Nicholson here one more time this week. This is example 4 in this video. So we're finding limits given a graph, and it's an AP style question, it says, but the idea is, it's trying to imitate an AP exam test question, and the reason is, they give you a graph like this. They love doing this. They give you a graph, no equation, and then they tell you to do something with it. And the reason they like that is with just a graph, you don't know what the equation is. You can't just plug the equation in the calculator, run some numbers, and figure something out. You have to really, at the core, understand what's going on because you don't have a calculator to help you. So, anyways, so that's our topic this week. So, what do you think? Can we get at it? All right. So, my son Quentin here is going to help us try and learn how to do limits of these graphs. So what grade are you in?
Third.
You're finishing third. Hopefully he's finishing third and going on to fourth. But anyways, before we go on to the example, I forgot to tell you, I need you all to pause the video and find a beautiful spot outside. If it's nice outside, I'm not saying wait until it's nice to do the video, but I'm pretty sure most of the week here that you're watching this, I'm recording this the week prior. The weather looks like it should be pretty nice. So pause the video, go outside, find somewhere comfortable, relaxing, and and then restart or start the video back up. So I'll wait. We'll just hang here. Okay. You wanna go get a snack? Okay. Let me do the video and then I sure will.
Okay.
Deal? Cool. So, all right. Well, hopefully you're all outside like I am. In fact, I was encouraged to give you a quick little tour of my classroom over the last 8 weeks now. So, yep. So my classroom has been the backyard and patio. So now that it's nice out, we're out here. Let's see, project number 9 or 10. Wife had me doing some raised bed gardens back there. Those are fun. A little landscaping. Let's see, what else did we do? Oh yeah, down there we've got a little sandbox area with a little kids pool, so we can kids can enjoy a little pool time there. But then we've got the above ground pool, 16-footer. Hopefully we can get that set up here soon and soon start enjoying that. And other than that, yeah, just our patio there. So, anyways, yeah, that's our backyard, my classroom. All right, back to business here. Limits on this graph. If you look at the limit or the graph itself, it's doing a lot, right? It's kind of crazy, but let's get at it here. First one, limit of the function as x approaches 2. The key here, as it approaches 2, it is not asking, what is the value of the function at 2. Let's see if I can, right? Because that's different. That's saying if I plug 2 into the equation, what does my y value become, right? Because that gives me a 2. The limit, however, is, let's pretend like we don't know 2. Let's just look at it from the left and from the right. Since there's no superscripts here, we see that as it approaches 2 from the left and the right, it works out perfectly. It approaches 1 from the left and it approaches 1 from the right. So our limit is then 1. The limit of the function as x approaches 1. Well, let's see. Here's x equals 1. And the problem is, at exactly 1, it equals 1, because there's our circled dot. The problem, though, is as I approach 1 from the left, it looks like 0. If I approach it from the right, it equals 1. When those one-sided limits are not equal, we say that the limit does not exist. D, N, E. Hold on. Phone call. Oh, it's Gray Mare. She can wait. I'll do these other ones quick. All right, so what is that? Mean Girls? That's a movie that, oh, what's her face? She makes some really popular line. Limit does not exist. So that is what happens when our limit from both sides is not the same. So then we look at our limit at x is approaching 3. As x approaches 3, well, as long as it approaches the same number from the left and the same number from the right, we get a limit. And it works out here. As we approach from the left, we get 2. As we approach it from the right, we get 2. So our limit is 2. This one, however, it is a one-sided limit. We have our superscript of a minus, which is good because if we look at our graph basically just ends at 4. So if we said what is the limit at 4, actually our limit as x approaches 4, just 4, is the limit doesn't exist because from the left it has a number. From the right, there is no function. It's just not there. So because it's just from the left with a minus sign, we're only looking at that, and we see that it approaches 1 as well. Here's another good one. We do have a graph, part of our graph on the left. We have part of our graph on the right. They do not approach the same value, but we can look at this one-sided limit and say, well, as x approaches 1 from the right, so let's see, from the right-hand side, we're approaching 1. As the function approaches 1 from the left, here it is, we're approaching 0. So the one-sided limits exist, the two-sided limit does not. And then here, we have a function limit as x approaches 3.5. Well, we don't have increments marked out for 3.5, but what we can see is that by definition, our slope is actually 1, and this is a large assumption here, but we're going to make it anyways. We're going to assume that this is a continuous slope from 2 to 1 and from 3 to 4. And in that case, our function says at 3.5, we're going to predict it to be right here, which is about 1.5. The same thing's going to happen for our other limit as x approaches 1/2. Well, here's 1/2. And again, our slope looks to be 1. It is an assumption. We don't actually know that because we don't know what the equation is. But we look at, it looks like a straight line, continuous. So we're going to come up here and we're going to assume that the value of the limit is also 1/2. Okay. So there it is. My screen just did a weird thing, sorry. But if you have any questions, please let myself know or any of the other 2 honors pre-calc teachers know. But that's all for today, and thanks, and hope you are enjoying the outdoors. But we'll see you later.